Okay, so today we're going to do solving systems of equations using Cramer's rule. Last class period, we solved systems of equations using inverse matrices. Today we're going to go over how to use Cramer's rule. All right, so we're going to talk about the formula, but first, before we talk about the formula, all right, let's do a quick recall of last class period. So let's say that I had this system of equations where I had ax plus by equals e and cx plus dy equals f. All right, before I do anything, I want to break it down into a coefficient matrix, variable matrix, and a solution matrix. So the coefficients of the variables would be the coefficient matrix. So A is the coefficient of x. All right, so this A is the coefficient of x. This B is the coefficient of y. This C would be the coefficient of the x on the bottom. D would be the coefficient of the y on the bottom. All right, and so those numbers would make your first matrix, your coefficient matrix. All right, and you would do it in the same order as they appear: A, B, C, and then D. All right, coefficient matrix. All right, then you will multiply that by the variable matrix. So the variables that I have would be x and y. Those would be represent my variables of my system. And that would equal whatever your solution would be. So the solution in this particular case would be E and F. And that would be your solution matrix. Notice E top, F bottom, E top, F bottom. Okay, so after you know what your coefficient matrix and your solution matrix is, all right, then you will be able to use those numbers and substitute in this formula. So Cramer's rule is actually how to find x and y by taking determinants. All right, so you would have a fraction. Your numerator would be the determinant of the solution matrix, where it replaces A and C, and B and D would stay in the same position. All right, so instead of A and C, we will replace that with the solution matrix, E and F. All right, B and D would stay the same. So you would take the determinant of these, all right, and then you would divide that by the determinant of the coefficient matrix. All right, so I'll say that again. I'll repeat that. All right, you would take your coefficient matrix, all right, as your numerator, except you would replace the first column with your solution matrix. So instead of A and C, I would have E and F. All right, and then the determinant on the bottom would be your original matrix, A, B, C, D. All right, to find Y, okay, we will replace the second column with the solution matrix. All right, so instead of writing B and D, we will write E and F. So A and C will stay the same this time. And now instead of B and D, I would have E and F. And again, the bottom determinant would be the determinant of the original matrix. All right, so you will find the determinants of the top and bottom. And then, of course, the last thing you will be to divide the top number by the bottom number. All right, so let's see what this looks like as an example. All right, so example 1, I have negative 2x plus 6y equals 4. And then I have 5x plus y equals 6. All right, so the first thing I want to do is write down my coefficient matrix. All right, so my coefficients are negative 2, 6, 5, and 1. So even though I do not see a number here in front of the y, remember, if there is no number in front of the y, that number is said to be a 1. Okay, so this would be my coefficient matrix: negative 2, 6, 5, and 1. All right, so those would represent my A, my B, my C, and my D. Sorry about that. All right, so those will represent my A, my B, my C, and my D. All right, then I will do my solution matrix. All right, so my solution matrix will be my 4 and my 6. All right, so that would be my E and my F. All right, so now that I know what my variables are, A, B, C, D, E, and F, I'm going to substitute that into my formula. All right, so I'm going to do X and Y separately. Do not try to do them together. All right, so this is the formula to find X. I'm going to replace A and C with E and F. All right, B and D will stay the same. So EF, BD stays the same. And then the bottom is your original matrix. So let's substitute. So E is 4, F is 6, B is 6, D is 1. My original matrix, -2, 6, 5, and 1. All right, now I can find the determinant. All right, so let's recall when we find the determinant of a 2 by 2 matrix, you cross multiply, okay, and then you subtract them. All right, so I would do 4 times 1 minus 6 times 6. All right, then I would do the same thing on the bottom. I would do -2 times 1 minus 5 times 6. All right, so notice how I keep my fraction together. All right, so I'm rewriting everything. Only thing I'm doing is writing the formula at the top for the determinant of the top, and I'm writing the formula for the bottom determinant. All right, so now I can simplify. All right, so 4 times 1 is 4. 6 times 6 is 36. My sign drops down in the middle. All right, then do the same thing on the bottom. -2 times 1 is -2. 5 times 6 is 30. My sign drops down in the middle. All right, then I will simplify some more. So now I'm going to do 4 minus 36, which is -32. And then I'm going to do -2 times -30, which is -32. And then the last step is to divide numerator by denominator. So -32 divided by -32 is 1. All right, so now I have X. Okay, now I'm going to find Y. So again, this is the formula to find Y. All right, so this time A and C stays in the same spot. And we would change B and D to EF, to whatever our solution matrix was. All right, so let's substitute. A is -2. C is 5. E would be 4. F would be 6. All right, and of course, the bottom matrix stays the same. -2, 6, 5, 1. All right, so then I find my determinants. All right, so you find the determinant by cross multiplying and subtracting. So I will cross multiply the -2 times 6 and then subtract 5 times 4. So here I am, -2 times 6, boom, boom, minus 5 times 4, boom, boom. All right, and then I do the same thing for the bottom. So then I would do -2 times 1 minus 5 times 6. So then after I do that, I simplify. -2 times 6 is -12. 5 times 4 is 20. Bring down my subtraction sign. -2 times 1, -2. 5 times 6, 30. Bring down my subtraction sign. Then I simplify some more. -12 minus 20, -32. -2 minus 30, negative 32. And then I divide. Negative 32 divided by negative 32 is 1. All right, so x is 1, y is also 1. So my solution set would be 1, 1. All right, and no, it's not always going to be the same number. It just so happens that this particular case, they are the same. All right, so let's do one more example. Example 2. So the first equation is negative x minus 6y equals negative 23. And then the second equation is negative 2x plus 5y equals 5. All right, first thing I want to do is write down my coefficient matrix and my solution matrix. So the coefficient matrix would be negative 1. So remember, if there is not a number in front of it, it is said to be 1. All right, so negative 1, negative 6, negative 2, and 5. Okay, so that will be my A, my B, my C, and my D. All right, my solution matrix is going to be negative 23 and 5. Negative 23 and 5. Solution matrix. So that is going to be my E and my F. All right, again, here's the formula to find X. So you have your coefficient matrix where you will replace the first column with E and F for the top matrix. And then the bottom matrix is just the determinant of the coefficient matrix itself. All right, so let's substitute. E will be negative 23. F will be 5. B will be negative 6. D will be 5. All right, and then you keep the order the same on the bottom. So that will be negative 1, negative 6, negative 2, positive 5. All right, then we find the determinant. So again, to find the determinant of a 2 by 2 matrix, you cross multiply and then you take the difference between those two numbers. All right, so that would be negative 23 times 5 minus negative 6 times 5. All right, and then I would do the same thing for the bottom. Negative 1 times 5 minus negative 2 times negative 6. And then we simplify. So negative 23 times 5 would be negative 115. Negative 6 times 5 is negative 30. Bring down my subtraction sign. Negative 1 times 5 is negative 5. Negative 2 times negative 6 is positive 12. Bring down my subtraction sign. All right, so now I simplify some more. Negative 115 minus negative 30. So remember, a negative times a negative becomes a positive. So this becomes negative 115 plus 30. All right, so negative 115 plus 30 is negative 85. And then negative 5 minus 12 becomes negative 17. All right, the last thing to do is to divide negative 85 by negative 17, and we get positive 5. So now we have our X value. All right, so now we want to find the Y value. All right, so again, here's the formula to find Y, where with Y, you keep your A and your C the same position, and you replace your B and your D with E and F. All right, so that you will find the determinant of this top matrix, and then you find the determinant of the coefficient matrix itself on the bottom. So let's substitute. A is negative 1. C is negative 2. E is negative 23. F is 5. And then the determinant of the coefficient matrix on the bottom, so that would be negative 1, negative 6, negative 2, positive 5. All right, so again, when we find the determinant of a 2 by 2 matrix, we cross multiply and then take the difference of the two products. So, -1 times 5 minus -2 times -23. And then we would do the same thing for the bottom. -1 times 5 minus -2 times -6. All right, then we simplify. -1 times 5 is -5. -2 times -23 is -46. No, I'm sorry, positive 46, excuse me. All right, so -2 times -23 is positive 46. Bring down my subtraction sign. -1 times 5 is -5. -2 times -6 is positive 12. Then I bring down my subtraction sign. All right, then I can simplify some more. -5 minus 46 is -51. -5 minus 12 is -17. And then I divide. -51 divided by -17 is 3. So that means y equals 3. So now I have my solution set. My solution set is 5, 3. X 5, y is 3. Okay, so you should have some practice problems already uploaded on Google Classroom. So you will complete numbers 8 through 14. All right, so you will complete numbers 8 through 14 on the sheet from last class period. Please make sure you are using the correct method for solving these problems. You will not get credit if you use the method of something else. So for numbers 1 through 7, you should have used inverse matrices. And for numbers 8 through 14, you should be using Cramer's rule. Okay. When you finish, please upload your work to Google Classroom. All right. You can do this by taking a picture and uploading it using your cellular device. Okay. Okay. All right, another thing that I want to let you know right now is over the break, I am going to give you a take-home test for matrices. All right, you can print it out or you can just do it on the computer. However, it doesn't matter because you will have to show your work on a separate sheet of paper. So when you do this, please make sure you number your questions so I can grade them accordingly. All right, but you will have a take-home test, meaning it is worth a lot of points because it is a test. Okay, but because it is a take-home test, it does mean you get to use your notes as well as any type of videos that you may be able to find. So I'm expecting good grades on these tests. Okay, all right, if you have any questions, feel free to send me a message via Remind, and I will respond as quickly as I can. Thank you for watching my video.